Welcome to the presentation of use cases and functional requirements of neural network watermarking. This is a project that we have started a few months ago, and we intended to develop a standard for neural network watermarking. Exactly what will be the standard and what kind of technologies MPI is requesting is the purpose of this presentation. So first, 2 words about MPI. MPI is a standard developing organization for AI-based data coding. It's driven by the idea that the media coding standards have made possible the big success of digital media. And MPI, moving picture, audio, and data coding by artificial intelligence, wants to repeat the same success by developing standards for data coding being the transformation of data from one format to another format that is more suitable for an application. What we do, and this is what I'm going to show here, is that we do not draw our attention to monolithic standards. We focus on components that can be composed into making complex AI applications. So the basic element is called the AI module. In this case, you see that you have a module whose function is to capture the speech of a person, convert the speech into text, but also extract the emotion that is embedded in the text. So this is an example of AI module. But if you want to make a complete, say, human-machine conversation system, you will need more than this model. And this is what is represented in the next figure, where you have a workflow that is a composition of AI modules with a certain function and certain input and output data, and the connection between the AI modules. All this is executed in an environment that we call an AI framework. So you see, you have the AI workflow with inputs and output data, and this is executed in this environment. You have a controller, and the AIMs can make a call to the controller via API. Then we have communication, global store access, and MI store. So this is the technical part, which is very important. But there's another important part, and that is it's good to make standards, but it's bad if the standards are not available, not accessible, or they are not accessible in a timely fashion. So this is what MPI tries to solve. Before initiating a standard, active principal members develop and adopt the framework license. This is a license, but it does not contain numbers. It does not contain dollars, does not contain values of percentage, does not contain dates where things happen. But the framework license says that the eventual license, not the framework license, the eventual license will be issued at a price that is comparable with similar technologies and not after products are on the market. During the development, any member making contribution declares it will make its license available according to the framework license. And after the development, members holding IP in the standard that has just been developed select the preferred patent pool administrator. So these 1 year ago were dreams. This is reality. We have developed several standards. For 4 of them, we have gone through this exercise, and there is a patent pool administrator working with the patent holders to develop their final license based on the framework license. So how do we develop standards? There is a proposal. Mihai, who will be speaking after me, came to MPI with a proposal. And I said, wow, by myself, and other people joined. Then we developed use cases. Then we developed functional requirements. And this was all done in an open environment, because what we think is that standards should be developed not just to serve the needs of those who have technologies and participate in a standards organization, but they should primarily serve the needs of people who will use the standard. So then this will be a Friday this week. The commercial requirements, the framework license will be developed. Then on the 19th of July, the call for technology will be issued. By the 10th of October this year, submissions are expected, and then we will start the development, and we will go to develop a standard. Before that, we will seek the opinion of the community by asking, what do you think of what we have developed? And this is a useful process, because we did make some changes based on what the comments that we have received. So what we have done so far, we have developed 5 standards, as I said, and we have a next round of MPI standards, which is AI Framework version 2. It is what I have described at the beginning, this environment where you can execute AI applications. Then we have another big standard that is called Multimodal Conversation version 2. And finally, we have neural network watermarking, which is what we are going to talk now, but that will not be me, will be Mihai.
Thank you, Leonardo. Thanks to everybody. So Mihai is speaking now, and through the next slide, we shall try to present you in a nutshell our work since we started this working topic in MPAI. So first of all, why we work on neural network watermarking? And here we have 2 main reasons. First of all is that machine learning, it's costly. Okay, we know that it's a very appealing field, that young engineers and young students came to us to learn AI and then go to you in industry, and it's a hot topic and everybody's interested in. But according to some statistics, buying already an off-the-shelf AI solution, can go as far as $300,000 and starts from somewhere around $6,000. You may also rent a pre-built module, and for professional level services, that will cost around $40K a year. So all these values are in dollars. So you see that the providers of the AI technology wouldn't like their solution to be unfairly used, to be hacked, to be pirated, and finally to lose the trace of their work. And the second point is that it's not that easy to precise what it's actually an AI inside or a neural network inside of a big end-to-end solution. So we may have solution combining alternative neural networks to provide an inference. It can be according to some service level agreement. It can be according to some type of data. It can be according to some particular usage. So you may have several blocks, and at the end, you may want to know which among the possible neural networks was actually used when the inference was provided. Neural networks can be shared among multiple users. I shall not start now the long discussion about what a user is. It's a particular, it's an individual, it's one user in an entity, but different identities can be hid behind, and so on. So keeping the track of where and how a neural network is used, it's also useful. And at a different level, neural network can be also altered before the provider knowing it. They can be embedded on a hardware, thus making even more difficult to track them, or they can be malicious attacked in order to change the inference. Just imagine what will happen with AI used in autonomous driving if it will be malicious altered. So identifying modification and being able to say that the neural network was not altered during its usage, it's also very important. So our project relates to the topic of ensuring traceability and integrity of neural networks. And if we spoke about traceability and integrity, sorry, next slide, please. The word popping up, it's watermarking. Watermarking has behind some 20, 25 years of history in the multimedia realm. But to make it simple, watermarking allows to imperceptibly and persistently insert some metadata into an original content. So imperceptibility means that although you insert that additional data, the task will be the same. So the neural network inferences will be not changed. The persistency relates, or also referred to as robustness, refers to the possibility of keeping that metadata, detecting that metadata, although the watermark neural networks, it's changed. So Carl put there between watermark neural network and watermark detection on this slide a kind of flashbulb to show that something happens there. The network was changed, maybe it was inserted on the hardware, maybe it was fine-tuned, maybe it was pruned, or something like this. Yet the watermark should be detected. And what is here a requirement? Everybody is expected to know what is the original watermark. I mean, maybe everybody might know what are the inserted metadata. Everybody might know how the data are inserted, how these metadata are inserted. They may even know where they are inserted. It's not an obligation. Yet the resilience, the security of the schema depends on a key that represents some very few parameters that should be kept secret. So watermarking, as inherited from multimedia world, means imperceptibility or fidelity. You don't change anything in the functional, in the operational functioning of the solution. Means robustness or persistence. That means once you inserted it, they are there, no matter how you modify the watermark content. And means some data payload, that is how much in bits the metadata are. So neural network watermarking, although conceptually it's inherited from the multimedia world, it's not a straightforward extension from that realm. Why? Because neural networks are no longer a static content, but a dynamic one. I mean, nobody tells you how much epochs you should train a watermark. Sorry, a neural network. After watermarking it, maybe somebody trying again the watermark model. The neural networks are not a static content, they are a function, right, rather than a content. And the second part is that the evaluation of the impact of the watermark in a neural network functioning, it's very hard to evaluate. So yeah, you insert some watermarking into a video, you watch the video, and even there, for all of you already, I already had the occasion to meet, you know how difficult it's to evaluate the artifacts in the video. But imagine that here, you change the watermark, and that watermark ensures a classification, and maybe that the result of the classification changes just a little bit, should not be a very severe modification. And if the task of that neural networks is to tell you whether it's a cat or a dog in internet, it wouldn't be a problem. If that task will be to tell you whether the patient is sick or not into a medical application, it will be a completely different thing. If the inference will be to tell your car stop or go on, it will be a completely different thing. So we cannot go straight forward and evaluate the impact of watermarking. Some general considerations should be there. So we need watermarking because it ensures traceability and it ensures fidelity, robustness, and data payload, but we cannot go straight forward and use what we developed for multimedia. Next slide, please. So how neural network watermarking behaves today? It's a very rich state of the art, despite only a 4-year history. So to the best of our knowledge, the first studies including watermarking and watermarking for neural networking were published some 4 years ago. So I precise, it's not using of neural networks for doing multimedia watermarking. No, it's watermarking neural network, as we already discussed. So maybe it was something earlier and we couldn't find, but anyway, this is something like the topic became of interest since 2018. And we have two typologies of solution for neural network watermarking. First one will be the white box. So that is the watermark is applied to the neural network in itself. It assumes that the user can access the model, the parameters, and the black box that assumes that the user cannot access the model. So the watermark should be recovered from the inference generated by that neural network. Next slide, please. Why, according to these items, neural network watermarking is a challenge? The fidelity depends on the task. It's clear that the way we shall evaluate fidelity would be not the same if the neural network relates to the classification. It was the example I presented just before, and it's practically the case of the most of the method published in the literature. And the case when this neural network will be used, for instance, in generating some speech signals starting from a text. So the difference will be very, very hard to evaluate. Maybe subjective evaluation should be combined with objective evaluation in order to have the good results. So here it's really a discussion to be considered. Next click, please. The robustness should be checked against specific modification. And while for some of them, for type of neural networks, these attacks can be a kind of, let's say, generic attacks, can be mundane application, mundane neural network processing operation. I speak here about pruning. I speak here about fine-tuning, about model compression or knowledge distillation. These are operations all neural networks are likely to undergo, and not necessarily maliciously. We can go also to adversarial attacks, and then that can be malicious. Data payload evaluation also differs from one to other, and actually in our efforts we decided, I shall see shortly, to keep it fixed as a parameter of discussion for evaluating fidelity, robustness, and next click please, and the complexity. So MPAI neural network watermarking will provide tools that will enable the watermarking technology providers to qualify their products. So we target the watermark technology provider and not necessarily the neural network provider. Can be the same, or can be the same business, can be the same entity, or can be different entities in the same company, or can be different companies. But with this standard, we do not provide neural network watermarking tools. We provide tools to assess the quality of existing neural network watermarking technologies. Next slide, please. So we identified the use cases, several, maybe next click in order to also see the synopsis. So we have a use case related to identify the ownership of a neural network, who owns this. To identify the neural network itself, we say, what if we define a kind of DOI for a neural network? And tools for verifying the integrity of a neural network. We structure them at 2 levels, as I already stated. So is the watermarking the neural network models, the parameters, the values, or watermarking the neural network inference. Next slide, please. So the scope of the MPAI NNW standard is to enable watermarking technology providers to qualify their products according to 3 items. The first one is relates to the imperceptibility. So the injection of the watermark without deteriorating the performance of the neural network. And in this respect, a testing data set to be used for the watermark and unwatermark neural network should be provided, and an evaluation methodology to assess any change in the performances of the neural network induced by the watermark. Second level, it's the watermark detector capability to ascertain the presence of a watermark decoder or of a watermark decoder to successfully retrieve the payload of an inserted watermark. So we have here 2 different use cases. One is to say, yes, a watermark is there, or no, a watermark is not there. It's a very binary answer. And for that, we call it watermark detector. Or a watermark decoder, and here we really consider multiple bit watermark. We consider that the data payload is big, and we want to successfully decode all these bits inserted there. So we search for a list of performance criteria for the watermark detector and decoder. This can be in the case of binary detection relative to the numbers of misdetection and false alarm, or in the case of the decoder can be a percentage of the retrieved payload. So we may say that the procedure works with, I don't know, 10 minus 6 bit error rate. It's just an example for making it clear. It doesn't have anything to do with the actual development of the standard. It's really just pedagogically speaking. We also need here a list of potential modification types expected to be applied to the watermark NN, as well as their ranges. So we invoke the fine tuning, the pruning, but which percentage, to what extent, and how. And the third item is the injection, the detector and decoder computational cost. By computational cost, because we speak about neural networks, we cannot go in number of operations because this will be too much experimental dependent, but we shall target execution time on a given processing environment. So we shall specify a processing environment and we shall measure the execution time, the watermark injector, detector and decoder required for achieving their task. Next slide, please. We have here an overview of what we just presented. It's a synoptic view. So we suppose that the watermark provider presented on the left of the image makes available an injector, an detector, and an decoder. Again, it's not necessary in real life and from industrial needs that these three components to be provided by the same company. There were cases in multimedia realm in which the injector was provided by some companies and then detector and decoder by other ones. But let's consider for the sake of clarity today that these three components are made available. And the MPAI tester, the one that will exploit the standard we shall create, will provide tools for the providers to evaluate the performance of the neural network. First of all, at the injector side, we shall evaluate the modification in performance induced by the watermark process, and we shall evaluate also the processing cost. And then at the detector side, we shall be interested in providing a binary answer: yes, this watermark was inserted there, or no, the watermark was not inserted there, even if the model is the one just watermark, or it was watermark and maliciously attacked. And at the decoder level, we'll be interested in recovering precisely, bit by bit, the inserted information. So what we shall standardize here will be the performance criteria for the detector and decoder, as well as the processing cost of the detection decoding phase. Next slide, please. The requirements are structured at the three levels we've just mentioned. So it's requirements related to the injection or to the injector, measure the impact of the watermark on the performance, and this relates to conformance testing dataset and evaluation methodology to assess the deterioration, if any, maybe there are no deterioration induced by the watermark, of the quality of the inference induced by the water. So the respondents are expected to precise the list of tasks of interest to be performed by the neural network, to comment on the process described in the call for technology. So this NXXX, it's written like this because it's the number will change, but it will be made available when the call will be released, and the method to measure the quality of the inference produced by the neural network. Next slide, please. Requirements related to watermark detection and decoding. We merge them on a unique slide because they are paired, however. So measures detection and decoding capability means explain the process of testing the detector and decoder of a watermark technology. And here again, to identify the list of potential attacks that will be considered in the standard. The respondents are expected to list the potential modification to be applied to a watermark neural network, parameters and ranges for that modification, and suitable distances to evaluate that performance. Why? Because even symbol error rate have sometimes different definitions, and maybe such a definition it's not of relevance for, as I explained, for emotional speech synthesis starting from a text. Next slide, please. Requirements related to the processing cost. We target here the processing cost of injection, detection, and decoding in order to qualify the neural network. So the respondents are expected to suggest configuration on which these computation costs are expected to be evaluated, like CPU types, number of cores, frequency, memory, GPU types, frequency, memory, and so on. And which measure to retain in order to characterize this parameter, so this item, sorry. So it can be the execution time in seconds, can be the CPU footprint in megabytes, and the GPU footprint, yeah, megabytes we expect it, but I know discussion it's open here. Next slide, please. So we are now at the beginning of this process, and these are the next step, but I think Leonardo will take over and will present.
Very shortly, just to summarize that we, on the 19th of July, we will issue 3 calls for technologies, one for the AI framework, one for the multimodal conversation, the one for neural network watermarking. The steps are here. After the 19th of July, we expect on the 13th of September, respondents to notify their intention to submit the proposal. This is a kind request to do it. It is not compulsory to do it. And if you do it and you don't submit, well, that's you don't submit. That's all. Then on the 10th of October, respondent are expected to make their submissions. On the 12th of October, we'll start evaluating the proposals, and then start drafting the standard testing. I mean, everything that is needed. Sometime in spring 2023, we plan to publish the standard. So this is all. So the only thing I want to say that you should join the fun and build the future.